So welcome to the fourth episode in a series where I'm giving some basic tips and tricks on how to program using Arduino. So in this episode I'm going to be doing a couple of different things. One of them is I'm going to be teaching you how to program and work with these LCD displays. And I'm also going to make the transition from Arduino IDE programming interface to the PlatformIO programming interface. So we'll get to that as we move forward. So first of all, I just want to talk a little bit about displays, just quickly, just to show you there's all of these varieties of displays. I think any of you that have seen my mini lathe series would have seen me using this. It's got some plastic protection on it, so it's not really scratched. But these are a TFT LCD shield. These are designed to plug directly into a Arduino Uno board, and I even have this is a 2.4 inch module. I even have this module here, which is a 3.5 inch version of that, which also has the same pin outs and can plug into the Arduino Uno. I suspect it also plugs into the Arduino Mega, but I've never used one of those, so I don't really know for sure. So that's probably something that will feature in the future. And beyond that, I have a lot of these little displays. So I think somebody might have seen this in one of my earlier episodes as well, which is a little I2C or I2C bus display. I believe it's an OLED display. I'm not sure I remember it correctly. But I have a whole bunch of these little displays. This is a 128 by 64 OLED I2C bus display. And what else have we got here? 1.3 inch. This is 0.94 inch. That's tiny. And this is an IPS display, so this would be a full TFT or full graphical display. And this little yellow and blue OLED display, and it's a SPI type interface. And you can see these pretty much all look much the same as you can see here. It's nice they put that in a nice little plastic box, right? And there's also these little peculiarities which I bought, which are these TM1637 style displays. So these are 4-digit with a colon in the middle here. 4-digit 7-segment display, which I suppose you could use for a clock or something like that. But the quirkiness of it is that this is just a serial type communication. You can see their clock and DIO and VCC and ground. That's all you need. And it does the rest to drive all those segments. So a couple of those. And obviously then we have this display as well, and this is the Hitachi style display. It's been around, I don't know how long it's been around, maybe since late 80s or something like that. This has been pretty standardized. I actually have and will be using in this demonstration a couple of these displays which were salvaged, I think, from sort of some type of government equipment. Somehow I managed to get some old garbage and salvage these. But the chip here says this HD4410, and the chip here on this more recent one, which more recent, but even so I still bought it in about 98. I think it says there 98 on the date there, right? So, but the chip here is this HD44780, and this HD44780 is the stated model number of the driver that's used in Arduino. So this, there might be some slight difference in the firmware between these two, but I've been using the standard Arduino driver on these older size displays, and they work fine. So I think the protocol is pretty much standardized. There are even the ability to do some customized characters on these, and I thought that with this older style display it may not have been supported, but it worked fine. So I'm not really sure what the feature set is different. You'll also find that there's a lot of different connector types here. For example, this connector type here and here, and this is actually pin 1 through to 14, so it's numbered reverse. But the pin outs seem to be pretty standard across all the different versions, if you know the pin order, basically. So normally they're actually, in the newer displays, they seem to be at the top here, and then numbered from left to right, 1 to 14 or 1 to 16, including the LED backlight. And for this one here, which I got in 98, was connected from 1 to 14 in the back corner here. But again, I'm pretty confident that these pinouts will be, from a labels term, pretty much the same. So, and just on the interesting aspect of these displays here, this is the most common one you'll see. There's 16, I think it's 16 characters across and 2 rows. This is pretty typical of what you'll see out there, and nearly all of them are. And however, when you configure the driver, it will ask you, the size, or you have to specify the size of the display. And you think, well, why? I mean, it's basically just this, right? But it's not just this. I actually have this one here from RS Components, which I must have purchased in 94, maybe something like that, 93, a long time ago anyway. And I bought it for stock and I'd never actually used it. And there you go. It's a 32 made in Taiwan ROC. Look at that. Let's get it out of the case here and have a look at it. Yeah, so connector on the side here, 1 to 14. And it's a 32 character wide and 2 rows. And the 2017 there, don't be distracted by that. It's definitely not 2017. Look at that, it says Taiwan 2017. Yeah, I don't think so somehow. But I can't see the driver chip, so this is probably some sort of Taiwanese clone of that style of board. Anyway, there you have it. For this demonstration, I have set up an extension to what we've been working on to date. So this is the arrangement that I've got here. And next up I'll explain in some detail of how I've connected it up, just so you understand. But it is exactly the same button arrangement and background LEDs that you've seen in the prior version. All I've done is I'm using this digital ports 8 through 13 on the Uno board to connect to here. And that's what we'll be using for this demonstration. Okay, so here are the pinouts for the display that I'm using. A lot of these displays actually have 16 pins, with pins 15 and 16 being used for the backlight. In my case, I actually have those on a separate connector on the display, so it could be one or the other. For now, I'm not really going to use the backlight because mine is broken and it's not really relevant to the discussion. I'm not really worried about it. Apparently the driver does have some support for the backlight, so if you want to use the backlight, you can figure that out yourself. So the first 2 pins are simply the power connections for the display. It's a 5-volt display as far as I know. I don't think it runs on any other voltage, so 5 volts. Pin 3, you need to set up a voltage divider, a potentiometer, so you can adjust the contrast going between 0 and 5 volts. Pin 4 is the register select, which we are using with the driver. Pin 5 we're effectively not using, but it's selecting between the read and write mode for the display. As far as I understand, we're only writing to the display. There's no reading coming back from the display, so you would configure that to be in a fixed write mode, so you would tie it basically physically to ground. The next is the enable. So these 2 control lines that are being used, this register select and enable, those are the core control lines which actually control the pacing and sending of data to the display. And the data itself is on pins 11 through 4. So in this case, it's a 4-bit connection, data 4, 5, and 6. And you can see how it's connected up on screen. I'm not going to go through them one by one. I will say that these displays, how I've historically used them in other applications, I've always used them in the 8-bit mode. You can see this is being used in a 4-bit mode. And obviously there's a configuration that you can do at the startup of the display to select if you're going to run in 4-bit or 8-bit. The simple point is that by having a 4-bit mode, obviously your code is a little bit more complicated because you're going to have to slice and dice your bytes and send them down. But the upside obviously is it's a lot less physical connections to your microcontroller, and if you don't have a lot spare, then obviously running in this 4-bit mode makes a lot of sense. I did notice that the driver that Arduino has supports the ability to have the 8-bit mode as well if you wanted to use it. Personally, I don't see the benefit. It might be a few cycles upside, but I think we're not talking about performance of these displays, and if we are, well then in that case you need to have another look at how it all fits together in a little bit more detailed level. For now, we're just going to deal with it on a very generic level in this discussion. We're going to use a display driver, a Arduino display driver, to connect up to this display. It's a very generic driver that's been around as far as I know, as long as Arduino IDE has effectively been out. And as I've discussed earlier, these displays have been around from probably late 80s, maybe even earlier. I don't have the exact history of these displays. The key things about these display drivers is just to get a bit of an idea of what they're actually doing, what's inside these display drivers, why do we need these display drivers. The reality is that you don't actually need a display driver to make these displays work. You can connect the bits directly to the microcontroller, and you can manipulate those bits and send the necessary control codes and flip the bits in a certain ways, and the display is going to work. And historically, that's how I've done it. I've actually written these in machine code, which is a bigger nightmare altogether. And flipping these bits and doing whatever, obviously you can do whatever you want. So you're not bound by using a display driver that somebody else has made, but it's going to help you out a lot. I mean, once you have these, it's going to get you going very quickly. And then if you need to review, you want to modify the driver that somebody's given you, or you want to write your own, case by case, you can decide how you want to deal with that. So let's have a look at what the fundamentals, or what basically we could say is inside one of these display drivers. So the first thing is that you have your application, you want to do a certain thing, you want to draw a line, or you want to do some text or whatever. That text or that line or that whatever you want to do is abstract in the sense of it's what you want to do, but it's not specifically exactly how the display is going to do it. So there's going to have to be some type of adaptation in the driver, something that takes your thing you want to do and turn it into something that the display can actually do. So there's some sort of data adaptation that's going to happen. And for an ASCII type or a simple LCD display driver like this, that's pretty much minimalistic. It might just mean making sure that the characters end up in the right place on the screen or something like that, or maybe that you're not using characters that are not allowed or something like that. But when we're talking about a pixel type display or a graphics type display, they don't have their own fonts. So if you say dump out this text, then it has to have a data adaptation. You have to take it from being your ASCII2 character code into being a bunch of pixels. So there's an adaptation there. Simply put, the typical adaptations we see is massaging of ASCII type characters for simple displays, and for pixel based, we're going to have a mix of either, for OLED displays, they're typically on or off. Grayscale, I don't think I've actually seen a grayscale display, but I assume out there. And then for your TFT or IPS type displays, your color displays, you're going to have something there again to do that adaptation for that. Next up, we have protocol formatting. So what is that? Ultimately, what we're talking about with protocol formatting is creating the correct sequence of command codes and data, or just command codes or whatever it might be, in an order that makes sense to what is compatible with the device you're trying to control. So you have your data that you want to send, but to send it, it has to be formatted in the right sequence to be able to get that display to actually understand what you're trying to do. Next up, we have the microcontroller's input-output formattings. The microcontroller will have a input-output capability that you're going to be using, whether that's parallel, whether that's an I2C bus or an SPI type serial interface. You're going to be interacting with the hardware in the microcontroller. And that's more often than not going to be more complicated than simply pumping bytes out the door. For example, in this case, we're actually dealing with a protocol that has been formatted in a sequence of 8-bit bytes that have to go out the door to the display, but the display is actually only connected with 4 bits. So we have to massage it. So we have to do this double shuffling. We're actually chopping up those 8 bits and turning them into 4 bits, or nibbles as I like to call. So this is the sort of massaging that has to happen, which takes that properly formatted protocol data and then actually gets it out the door of the device. So let's have a look at it in the case of this particular device we're looking at. We're looking at a liquid crystal display driver. Data adaptation is very simple, ASCII2 type, so it's very minimalistic as to what's actually happening here. The protocol formatting is in this HD 44780 Hitachi, historic format for sending to these LCD displays. And the I/O formatting is actually parallel. In this case, it's actually 4-bit parallel with those two control lines. And it looks something like this, right? Microcontroller, a bunch of lines connected to the display, and that's it. Now, I had somebody, and I'm sorry because I can't remember the name, it's been a while since I looked at the comments, someone in the comments who asked me they wanted to connect this LCD display using some other device. And I didn't actually understand what this was all about, so I went and researched it and had a look. And what they were talking about is this PCF 8574 It's a parallel over I2C bus type connection. It's actually I think they call it a port expander. It gives you the ability to expand the number of parallel outputs, and I think it might do inputs as well. I can't remember if it's I and O. But in any case, that has the big benefit of being able to have a lot less outputs or inputs being used on your microcontroller, so you can actually reduce the number of inputs and outputs on your microcontroller. And I guess the other upside is that you could have a whole bunch of these LCD displays or whatever on this I2C bus, and you could talk to them all just on the one I2C bus. And if we're talking about savings as far as port numbers on the microcontroller, you could be talking really, really large savings here. Obviously, the downside is, there's really probably two downsides. One is that obviously the interaction could be a little bit slower, but for a display like this, probably not going to make any difference. I'd say the other downside could be the fact that there is more overhead for the I/O formatting in the microcontroller, because you're going to have to manipulate the data a little bit more to get it to the display. But again, it's probably not that critical. So when I do the demonstration, I will show how you can use this PCF8574 to make the connection with the LCD display. Unfortunately, I don't have one of these chips, so I can't physically connect it, but I'll show you in code how you would do it. It's pretty much seamless. There's a few different people who have made fairly seamless drivers for that, and I'll demonstrate, or at least I'll show you one of those implementations so you can use that if you want to use that. Other than that, the actual driver itself as to what it can do and what the display can do, I mean, it's going to be the same. So all of my demonstrations are going to be in this direct connect 4-bit parallel connection, but again, there's no reason why it couldn't be using this PCF8574 chip. Anyway, let's get on to doing some programming. Okay, for this demonstration, we're going to use the library called Liquid Crystal. And here it is. You can see that it says it's a built-in library, and you can see that it also is this HD44780 or compatible, which in this case is we have a compatible one chipset, and it can support 4-bit or 8-bit mode. In this case, we're going to use 4-bit mode. Alright, so that's obviously already installed as it's built in, and it's a official Arduino library. Pretty straightforward stuff. So let's use that and get going. So the first thing we're going to do is include that library, and we're going to initialize the object basically. So the liquid crystal type object, and we're going to call it LCD, and these are the port setups that we're going to use. And as this is an Arduino IDE, it's not going to tell us much about what is what. We would have to go look it up, which is a pain, but I already know that for the 4-bit mode initialization, it's RS, EN, and D4 through D7, and I have them just in a straight line, ports 8 through 13, so nothing complicated there. And next up, just to get it working, we will initialize the display. Let's get rid of this. So the initialization is pretty straightforward. You just have to specify the size of the display. In this case, it's 16 columns and 2 rows. And just in the setup here, I'm going to send just a little bit of text to make sure the display is working correctly and we've got everything connected up correctly. So the function is pretty straightforward. LCD dot, and as you would expect, print. I'm using the F style function here to save RAM on the Arduino Uno, as we've discussed in prior episodes. It's the way to do this. And let's compile that and see that it's working. Also, there you have it. It's pretty straightforward. Display's okay, so we know it's working. So we have a connection and it seems pretty good. Let's do something a little bit more dynamic. In the loop here, let's update the current second. So this set cursor is column and row. It's a 0-based position, so 0 to 15, and 0 and 1 would be only 2 rows we have here. So this will be the second row, first character, and we will just LCD print the millis divided by 1,000, so seconds, and I will have a small delay just to stop the hammering. Nothing too complicated, right? Okay, let's send that and have a look. And there it is, working fine, counting away the second, so nothing too complicated there. So while we're still here in the Arduino environment, I wanted to show you how to use that PCF8574 I2C bus expander chip to drive the LCD, because there's some drivers already out there. And let me see if I can find it here in the libraries. I haven't actually searched it. So here's one here, this liquid crystal PCF8574. There are a couple of different ones here, and I'm sure you can find one to suit your needs. But let me just show you this one anyway. I haven't got it installed. Maybe I'll install it. It's pointless. I don't actually have this chip here, so I can't actually demonstrate it for you. But anyway, let's do it. The code would look something like this, however. So first of all, we need to get rid of this liquid crystal object because it's included for this liquid crystal driver, because we're not going to use that one. We're going to use the modified one, which is this liquid crystal PCF8574. And we also need to include the wire or the I2C bus library as well. So we'll get rid of that. And then the initialization is going to be a bit different as well, because we're using the I2C bus. Now the I2C bus on the Uno, I believe there's only one, and so you don't need to specify the physical ports or anything like that when you initialize it, but you do need to specify the addresses, etc., of what you're trying to talk to, so you need to know the address. And I think that PCF8574 actually has the ability to change the address as well. I'm not really sure, so you'll need to check that yourself. But for now, the demo code that I had it as 27, so possibly that's the default address. So the initialization just looks like this. It's obviously the library name, and then again the object, and then the hex 27 address for the I2C. And you can see fundamentally it's doing the same thing. Here we're just telling it the I2C address. However, in this case we were telling it the physical I/O ports for the parallel port. So we don't need that. And in theory it would be nice if that was complete, but it's not complete, because in this implementation, as this person has done it, the LCD begin doesn't do all the connection processing, and it's probably not a bad idea that it doesn't either, because you really need to go and check. In the real world of I2C, you need to go and check if the device is actually there, if it's the right device, and all this sort of stuff. We're not going to go that far in this demonstration, but I will show you a short initialization process for the I2C port. And then once the I2C is initialized, everything else is exactly the same. You don't need to do anything at all tricky. So let me just paste this in here, and then I'll give you a quick explanation about what it looks like. So this is the initialization routine that I'm using, and it's pretty much from the demo code from this person's driver. I'm using a serial begin just to open up a serial port so we can have some way of reporting the status to somewhere about what's going on with the connection. This integer as error is being set up with a default value of 1, and I'm doing this while routine here. And so first, inside this while, we're saying, if it's not connected, or if the error is not equal to 0, and if it was equal to 0 it would be connected in that sense, then we're going to send the wire begin. We're going to wire begin transmission to the address, hex address 27, and wait for the response of the end transmission and get the error code. We're going to print that error code to the serial port, and then obviously it's going to loop back here, and as long as it's not equal to 0 it's going to keep trying to connect basically. But we assume that on the first run it's going to be connected, and then once it's connected then the rest of these LCD commands will work as fine. Now there's one thing I don't like about this code. I wrote this delay 2 seconds because I was thinking that you could wait 2 seconds between every retry, but the code is a little bit broken, so let me modify it a little bit to make this conditional. I'll only do the delay if it failed. So if error is not equal to 0, in other words, yeah, same thing, right? So if there was an error, then we'll have a small delay before we go back to the retry and stop hammering. So the net result is it's just going to get hung up in the setup routine here until the connection is established. And once the connection is established, it's going to keep working for as long as it can keep working, I guess. Look, this is a terrible piece of code. I wouldn't write it this way. There's no checks or balances. Serial communication and bus-based communication is a tricky environment. You really need to make sure the device is still there and communicating at certain intervals, and there's no checking for that. We're doing this initial check for the connection. Once we get the connection, we just use it and assume everything's going to be okay. But and it probably is going to be okay. But personally, I wouldn't do it like that in a serial bus or a addressed bus type situation. So anyway, there you have it. For those who wanted to know how to use the PCF8574, that's the initialization or the setup of the object and the initialization of the connection, and then pretty much everything else is exactly the same. So for this demonstration, or the rest of this discussion, I'm not going to talk about this PCF8574 I2C bus type connection, but if you're using it, everything else in the discussion is valid. You just need to connect to it using this tool if you want to use that. From here on, I'm just going to stick to what I have, which is this parallel connection. Alright, so next up, what I want to do is take this exact implementation and get this working in PlatformIO. Because PlatformIO is definitely the place we want to be. We don't want to be working in this Arduino IDE anymore. At least I don't want to be, that's for sure. And I'll show you why when we get there. Alright, I want to say up front that this is not meant to be a full tutorial on PlatformIO or how to use it or anything like that. This is just meant to be a bit of an introduction and to get you on board, because I think that everybody out there should be using this and not Arduino IDE. Now I think there's a Arduino IDE version 2 coming out, or that has come out, or it's rumored to come out. I haven't looked at it, and to be honest, I spend enough time on getting away from it that I probably may not go back. And I hope it's good, but I'm not sure it's the right solution. I think time will tell on that. So for now, this is what we're using. In any case, all of this code is still Arduino. That means that you can move this code, or you can use whatever code you see me writing in this PlatformIO, and you can write it in an Arduino IDE, and it should be no problem to work. So there's nothing changed in that sense. It's still just Arduino code. It's just that the development environment is far, far superior. It's really just hard to overexpress how immensely different it is, and I think that's what I want to impact on everyone here. So first thing you need to do is you need to go and download this free piece of software called Visual Studio Code. You see the name up the top here, and install that. And Visual Studio Code seems to be some type of a container for development platforms, so you can have multiple different languages and platforms, and it provides a generic environment for developing in, I guess. So in this case, I've downloaded and installed this PlatformIO module. I don't remember exactly how I did it. I'm sure there's tutorials out there. I expect it was as simple as installing Visual Studio Code and then searching within the Visual Studio Code application for the PlatformIO module and then installing it, and that's about it. So I assume you've gotten that far, and then you can follow along here with me. Talking quickly about what the big differences are, and you'll see some of them as we go. One of the huge differences for me is having the ability to have multiple different microcontrollers configured in the same system and being able to switch quickly between them. This was never easy in the Arduino IDE. Every time you open it up, you would have a different configuration. The configuration would be lost. You know, moving from one microcontroller to another is always a nightmare of trying to remember how you had it configured the connectivity and what options to use, etc., etc. Here, in the case of PlatformIO, the configuration is in each of the individual projects. So you can actually copy and paste that between your projects to quickly recover the configuration for connectivity. It also means that whenever you open a project and you're working in a project, the connectivity or the serial monitor, etc. configuration is all carried with the individual project. And this can't be understated as to how much time saving that is if you're using a number of different microcontrollers. So here, for example, you can see one project I've actually gone through and I've configured all of the different devices that I'm using. So let's have a quick look. ATtiny85, ATtiny1616, Arduino Nano 328, the old version, apparently there's a couple of different versions, Arduino Uno, Black Pill 411CE, Blue Pill 103C8, the 128K version, and what else have we got here? And we've also got the ESP32 development module as well, which I'm using recently as well. So all of those in here, easy to switch between any different project. Have a quick look here at the configuration for how it's going to work, or what platform it is, all in this PlatformIO ini file. And you can see here it's saying the platform, the specific board, the framework, which is Arduino obviously, and build flags, the upload protocol. So all the information you need is here. And obviously it varies between each different platform, but as long as you have the right information in here, it's going to work. So that's great. Alright, let's get on to making this new project. Of course, I've already tested this offline, so I know this is going to work, but I'm going to step through it with you in any case. We will do Uno liquid crystal. And then we select the board and we can just go Arduino, oh God, Uno, and there it is, Arduino Uno selected, and the framework, etc. is all automatically selected. Finish. And this can sometimes take a little while to load up, but in this case it's pretty quick. That's good. And we see the configuration here. So liquid crystal, right? Okay, so here is the project that we're working with, this Uno liquid crystal. The PlatformIO is what automatically is opened here, and all of these other things I'm not going to go into much details. I think the key thing you want to know about is this source folder where the main CPP is. And if we look at it here, the void setup and void loop is exactly the same as with the Arduino IDE. The only thing that's different is that you need to have this include arduino.h at the top here. Otherwise it's exactly the same. So obviously that's not necessary in Arduino IDE. I guess that's because it's multi-platform compatible. You have to include the platform root core code in the reference as well. Alright, let's see if we can get this code to work that we wrote in that other thing and see what happens. So the first thing we want to do is, just as we did with the other application, is include liquid crystal H. Oh, see, we've got an error then. Now look at that, straight away we get an error. We can see while we're writing that's an error, and it says it can't open the liquid crystal. So this is because even though in Arduino IDE this is a built-in module, it's not in built-in module in PlatformIO, so you need to install the modules. The good thing about installing the modules is once you install it, it installs the local copy of the version you were working with into the folder of the project you're working with. So that's quite good, because in Arduino IDE you could actually get an update that snuck in and destroyed your code at some point, but as far as I understand it, that can't happen with this. Anyway, let's get to the point. We need to install liquid crystal for this project to get this error to go away. So we'll go to the PlatformIO tab here, and there's a option here called libraries, or a tree item called libraries. We'll select that. That seems pretty straightforward, and we'll search for that liquid crystal, enter, and 29 libraries, that's a lot. Let's have a bit of a look what we've got here. Oh, you'll see here liquid crystal I2C, and there's some other custom versions, etc, etc. I2C, this Matthias Hotel, that 8574 one here. So yeah, it's all pretty straightforward. So how do we actually get it in to the project? And actually at first I was a bit confused. We're going to use the liquid crystal one here, which is the, let's click on that, see what happens. And we see we have the demonstration code here, which is sort of nice. Add to project. Yeah, liquid crystal, this must be the version of the module that we're going to copy across, 1.07. And select a project, and this one was Uno liquid crystal, that's the one we just made, right? And add. Okay, it's done. So if we click up here to the Explorer, we get back to where we are, and we go back to that main file, and the error has gone away. That's great. So I'm a little bit intrigued to see where all this stuff goes. We have a look at include. Nope. Is code. Nope. What about? Nope. Yeah, it's a bit of a mystery. What about if we have a look at the PlatformIO? Oh, well, there we go. Live dependent trees, Arduino libraries, liquid crystal, and the version number here. So that's locked it in, and that's where the dependencies are included. Okay, fine. So let's do what we did before. LCD to begin, and oh, okay, I haven't copied the. Let's initialize that device first. Okay, there we go. Liquid crystal, exactly the same. LCD and the 8 through 13 pins that we're using. LCD begin. Let's add a comment. Hopefully that error is going to go away in a second. It's gone. And let's do that same thing we did last time. Same order, same thing, just to see that everything's working okay. Alrighty. Maybe what I'll do is I'll do this in lowercase just to make sure that we have the right thing. So just before I actually have a look down here, there's a few different options down the bottom of the screen. PlatformIO build, same as the build. Upload, which I'm assuming also builds like Arduino. Clean, which obviously cleans all the build files. I don't know what that is. Serial monitor, yeah, we know what that is. That will give us a serial monitor. And new terminal, I don't know what that is. And this one here, switch the default platform. This is pretty critical. And what happens is when you have a lot of different files open here and you hit the build, it will actually sometimes build, you don't know which project, right? Because, well, which project is it meant to build? Which one is it working on? Which is the default? And I had a bit of trouble figuring this out, but it's down here. You open here, you select on the one you want to build. In this case, it's already correct. Liquid crystal and default, and there it is there. So anyway, if you get lost, click on here, and before you build, just make sure you're building the right thing here as well. I think that's a little bit confusing, but you know, not everything's perfect. Let's try and build it. Let's see if it works. And we'll upload it. Hopefully we'll build. Lots of things going on. Looking for a port. Yep, seems to have detected it. That's cool. Success. Alright. And if we look at the screen here, we see this is a lowercase OK. So we know we're in business. So we know now that we're cooking with gas. Visual Studio Code, PlatformIO is working fine. So let's just put in that other bit of code that we were running before, just to make sure that everything's working. Exactly the same. Upload. And I think it's pretty quick. I'd say it's nearly quicker than Arduino IDE, that's for sure. Yeah, I mean, I think it is quicker actually, so that's always a big plus. So yeah, there on the display there, it's working fine. Now, I wanted to just quickly highlight one thing about PlatformIO, which I really like, which is the autocomplete or auto suggest, or what do you want to call it. If I want to know what this LCD object can do, if you're in Arduino IDE, you really don't have any idea. I mean, for example, if I'm initializing this LCD here, I had no idea what is what. I'd have to go to some reference book and look it up and figure it out. It's a total joke that it has to be that way, because all of these files, all of these C-type files, actually have full definitions and actually will tell you how it actually works. So, you know, it's ridiculous that the IDE doesn't actually tell you what is what or what you can do. So if I go in here and let me just delete this and see if I can get the suggestions up. Here we go. So here it instantaneously shows me what options are available, and we can see this is probably the one that we're using, maybe or not. This one here has a read write. This one here has D0, D1, D3, all through D7, and it also uses a RS and the enable. This one has the RS, the read write. I don't know why they have the read write and the enable and the 8 bits. So you can see you can initialize it in all different fashions here. And so there you have instant ability to understand how you've initialized. But not only that, once you've defined the object, you can go and figure out what sort of features and functions the object has. So if I go LCD and press dot, oh, I've broken this, sorry. There we go. See, not only did I break it, it showed me where I broke it. How wonderful is that? So LCD and then dot. Now we can see all of the commands that are available here, and you know, we can pretty much guess what a lot of these things are pretty quickly. I mean, no blink, no cursor, no display, set cursor, blink, clear. There's a whole lot of features and functions here that you can figure out just by looking at these auto suggests. So I'm not going to go into all of the functions of the display here. We can probably guess what some of these could be. So especially related to having a cursor or a blinking cursor or not blinking cursor or things like that. And we could just test and use them. And even if we don't know what they are, we at least this stimulates us to go and do some research about what sort of functions they have. For me, I just get sick of looking at the manuals, right? If I have to write and do a bunch of research every time I'm trying to write something, I'll just try and work around it half the time. And I know it's terribly lazy, but they say time is money, right? You can't just sit there spending your life researching stuff. Sometimes you just have to get it done. So this is why I think this is so much more critical to being able to get you in the know about what's going on. And to be honest, I wouldn't use anything else. All right, with this little bit of weaponry now in mind, what I'm going to do is I want to use this, there's something suspicious here called create character. And what that does is it allows us to actually define a customized character. And I don't really... Oh, there it is. It says, allows us to fill... Look at that, it even has a description. I mean, God, you don't even need to go to the reference. Allows us to fill the first 8 CG RAM locations with custom characters. So you can have up to 8 characters, 1 through 8, and you can have a customizable character. Well, that's pretty cool. So all we have to do is supply it with the address, 1 through 8, and we need to provide it with an array of bytes for the definition of the character. So I already defined a character, so let us try and use it and have a look how that looks, just to, it's a little bit of a side note to give you an idea about what these displays can do, if you want to do a little bit of messing around with graphics. So I've defined 2 characters here, just like that, and I defined those by doing it in Excel. So you can just see here in Excel, these are the characters that I just defined and figured out the bit arrangement, which matches up with this 00100, 00100, 00100, and 01110, etc., etc. And so these are the 2 custom characters that I'm going to define, and you can have up to 8, obviously, as per the earlier description. And just after I do the LCD begin, I will define just like that. And something I found out about using the definition here is it seems to mess up the cursor position. So we need to set the cursor position back to 00. And to use those custom characters, we need to use a backslash, I think it is. Backslash. Let me just copy and paste it. So yeah, this backslash and then character 01 and then backslash character 02. So that will show us those 2 characters. Alright, let's just see if that works, and then we'll move on to the next thing we're going to do. So, definition of the characters, then define the characters, and then show the characters. Alright, let's see if it works. So there you have my 2 little custom characters. Pretty cool, right? Alright, so that's it for this. Next up, what am I going to do? There was a request that I had, is if I could give a demonstration on how to use the up-down keys to adjust a value on an LCD display like this. So I'm going to do that. I'm going to try to keep that really brief because I think it's not interesting. What I'm going to do then is I'm going to flip over to taking that menu that we wrote in the last episode, that we've been carrying on through episode 1, 2, and 3. And we're going to bring it into this PlatformIO environment and first see if we can get it to work. And once we get it to work, then I'm actually going to add the ability to actually use this LCD display to run that menu, which I think is a little bit more interesting to most people. Alright, so I'm going to keep it short and sweet. First off, let me just delete a bit of this garbage. And I'm going to do a little bit of formatting just to make it a bit easier to read. My setup bracket. Main loop bracket, so we can all see where we are. It's much easier to see in here anyway, it's not that necessary, but still I'll do it. And we have 2 buttons, we're just going to use the up and down button, so I'll define those positions and we'll set those up. So the constants A2 and A1 for the up and down. We'll do the basic setup for those 2 buttons. Pull-ups, you've seen that before, nothing too tricky there. And I'm going to put a little bit of a default message on the screen for the up-down settings. Just says adjust value, right? Cursor 0, 0, adjust value. We probably don't need that cursor 0, 0 since we're not doing that messing around with the character. So let's get into the main loop and things get a little bit more serious. I'm not going to explain this in great detail because this really just follows what you saw in the last episode. So if you didn't see the last episode, go and see it. But I'm just going to put it in here again quickly just to save some time. We have the loop tracker, which I always have in my menus, and even though this is not a menu, I'm still going to have a loop tracker for my main internal loop inside this loop. I'm going to have the value, which I'm working with this test value to be manipulated 500. And I'm going to use my repeat button control function, which I explained in the last episode. And for that, we're going to need these two variables, this repeat count tracker and the last time the repeat was made. We also track, just as I do always, the was down states. And finally, just before we get into this main loop, I will display the current value, the value of this test value here on the LCD screen. And the main loop is a eternal loop, and in this case it really will be eternal. You know, in theory I could move all this stuff here probably up to here and make some of these values global or whatever. It would probably be correct as well, but I think I'll just keep it in the same structure as the menus that I've been doing in the prior episodes, just to keep some consistency. Whatever floats your boat. Why is that? One bracket too few. Here we go. That's quite good. It had a little red thing. You see that? Watch this. If I get rid of one bracket, it thinks it's from here to here, this blue, and here we have a red saying there's a lack of bracket, which is sort of nice. But I don't see any error, which is not very nice. Anyway, can't expect everything. Alright, we close that bracket. So this yellow bracket is here. So the colouring is nice. You can sort of see where the brackets start and end. These awful brackets. Alright, so our main loop, and the first thing we do when we enter the loop is we capture the current millis, and we capture those button states. Alright, I like these little lines here, it's where you can see where the loop goes to and from, right? It's pretty cool, right? And so let's manipulate that test value. You can see it's complaining because the button is down routine is not installed yet. Why don't we just do that now before I get too far along? I'll just copy all my button pressing tools in the bottom here. So we have the button is down routine and button is up routine and the button repeat routine, all explained in prior episodes. So if you want to know what they're all about, you can check them. If you want to look at them here, you can see them here. Okay, anyway, so we capture the button down states for up and down buttons, and the error's gone away from these functions as we can see here, and we're going to manipulate those test values. I don't like that it doesn't give you the bracket automatically. I don't know why there's an error here. See this? Button accept was down. Oh, yeah, don't need that. Sorry. Isn't that nice? See, you get it straight away. Alright, so these are the call function here. So this is the button repeat test for the down button and the button repeat test for the up button. And then if neither of those are valid, we're going into the cleanup states. So let's do the cleanup states first. They're pretty straightforward. Button cancel was down. We don't have one of those. So let's get rid of that. Oh god. Alright, sort of easy, right? So we just clean up the button down states for up and down, and we clean up the repeat count. Alright, as again, these are all explained in a prior episode, so that's why I'm not really covering in great detail. So inside each of these, when the down is active or when the up is active, we need to do something. And what we're going to do is do a test to see that in the case going down, we want to make sure it's not too small. And where are we? Test value. So if the test value is greater than 0, then we can decrease it. So the test value minus equals 1. And then we're going to draw it on the screen here. So set the cursor, print the value, and I'm printing after it these bunch of spaces. That's to make sure that we clear off any unwanted digits that might have remained for when the value is something else. In theory, I could just have one space and that would be enough, but I've got 3, doesn't matter. And inside here, we're also going to have to clear all of these button states. I'm just going to paste that in here because that's common. May as well copy this, except we're going into the other direction, and we're maxing out at 1000. So if test value is less than 1000, then we'll plus equal 1 and do the value. Alright, and at the end here we need to have our pacing. So what do I like so far about this interface? And to be honest, I haven't used it that much. The first thing, it's quite easy to track where these bracketings start and end. That's quite nice. And obviously the coloration is really good as well to be able to visually separate different aspects. Alright, so set up our variables, show the initial value, get the loop into time and the button states, check for if any of the repeat states are valid, otherwise do the cleanup action, and if one of the repeat actions are active, then we will test to see that we can make a modification. If we can, we'll do the modification and update the display, and no matter what, we're going to clean up these down states to make sure that we can detect it on the next round. Okay, let's see if we can build it. 4 problems. Button is down, was not declared in scope, button repeats. Look at all these errors here. A second ago this was fine, right? So why are we seeing this like this? Well, in fact, I already know the answer to this problem, and this is a problem. I'd say it's a negative for PlatformIO. I don't know if they're going to fix it or not, and I don't even know why it's a problem, but it's to do some sort of difference between the error detection when you're coding and the error detection at compiling, and it just shouldn't be that way. But the point is that for some reason or another, is the definitions need to occur before you use them, which is annoying, basically. Yeah. So what I'm saying here is that button is down or button up is being defined after I'm actually using them, and so that's what it's complaining about. So the simple solution right now, even though I don't like it, will be to move this up to the top, basically. So I'll take all of my button pressing tools and shift them up even above the setup, just past definitions, and put it in there. And hopefully, I don't even, oh yeah, these are just the compile errors remaining. Hopefully we're going to be okay, I don't know. Makes me nervous. Let's see if it works. Build. Success. Alright, so the error's gone away, and in theory this should work. And download it. Well, done. And we see the 500 value has started. Down. Oh, up, sorry, this is the up button, and then up. Up, down, exciting, isn't it? And if we hold it, we should get the acceleration and off to the races, right? Stop, done, 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 done. So let's try and go for 450, down, works good, right? Alright, well that's it for this. Next up we're going to get that menu structure that we've been making in the last couple of episodes, and we're going to bring it across into PlatformIO and see if we can get it to work. Alright, so I've copied the original code from the Arduino IDE into the clipboard, and we'll just paste it here. I think I'm going to leave this LCD stuff up the top here because we're going to use it again later. It's irrelevant for now, and I'll just copy over all of this. See what havoc we can create. So according to our experience just a few seconds ago, we can expect that the order of these are going to make a bit of a mess if we try to build this. So let's see if we can build it. Of course, we're going to get errors. How many? Heaps. 55 errors. And as expected, all of these things are complaining about things being out of order. First one is up here, this main loop. because it's referring to all of these submenus and things like that, and they're all at the bottom. So I'm just going to shift this straight away to the bottom. I'm just going to brute force it. I don't really like it, but it's not that critical. And build it again. Clear screen, print divider. So why don't we just move all of this stuff here at the bottom? Draw all the tools. We'll move that to the top, right? Where are my tools? The tools display through to, and including this weight, right? And leave the main loop there at the bottom. Control X, shift everything up to the top, just above the setup, and build. Oh, one problem. Signed and unsigned integer comparison, because I've got this wrong here. So this is a historic error. It's just pointing out. Let's just fix that. UN32. It's not really an error, but build. What did I get wrong here? Oh God. Try that again. No problems. Look at that. Very good. So, will it download and run? So it's downloaded okay, and we can see here the background tasks are working. Obviously the LCD display is dead, but we need to see the terminal or the serial monitor or whatever we want to call it. This one here. Click this and we get garbage, right? See here at the bottom? This is oh, I know what this is. So this is another peculiarity with PlatformIO that we need to get you familiar with, and that is that the configuration for the baud rate for connecting to the serial monitor also has to be defined in the INI file, and I haven't got anything defined here. There's a lot of help online as far as the different platforms and what sort of options there are, but this here is a generic option, and it's just called monitor speed, and you can also probably select the monitor port and a few things like that if you look it up. A bit of research and you'll find it. But in this case, the main code, if we look at the setup here, I'm using 115200, and so now the monitor speed 115200. Let's just resend it and rebuild it. It's total overkill. Hopefully it will get that terminal up and running, or that serial monitor up and running. Oh, that looks something familiar. Make that a little bit bigger. Let's see if it works. Okay, I've got my buttons here. I've got my fingers down. UI test buttons. That's weird. I pressed enter and I went into there. Let me just check. I think there's a small bug. Main. This was for second menu, root, submenu 1. Here, root pos. Looking at the wrong thing. Then we should be looking at the sub pos. One more time. It's much easier. Okay, and where's my terminal? There it is. Okay, so it looks pretty much like what we were getting in the Arduino IDE. Now I know in Arduino IDE there's this serial grapher and a few other things. I've never used those. I guess they could be useful, but I'm not sure if that is available here or not. But the terminal works. It's a little bit different. It's not a sub window. I don't know, maybe you can pull it out as a sub window, but okay. But I think we have achieved what we wanted to achieve. So next thing is we want to get this to work on the LCD, and that should be pretty easy to do. What I'm going to do is I'm going to leave all of the serial stuff there. I'm not going to take it out. I'm just going to layer on so that the LCD display also displays something meaningful. Okay, so here we go with the final bit. Let's get it done. Now obviously you wouldn't normally leave all of this menu related serial code if you're actually making an application. But for this, I'm going to leave it there just to sort of keep the link between, you know, what we've seen so far and what you're going to see on this display. Now, obviously, there's not much space on this display, so we're going to very much have to limit what we're going to show. Let's get it done anyway. Where will we start? So, start at the setup. We better initialize the LCD object in the setup. I don't think we need to write anything to the screen there. We're going to do it straight as we get into the root menu anyway. So there's going to be a generic part of the screen. There's two lines that we can really use. So the first line I'm going to use is to describe what screen we're in. We'll write that just as we get into the menu, right? So this is the entrance into the root menu. Just before the loop, I will do a title screen title or whatever at 0, 0. And I'm just going to write main menu. Now, I've purposely written this 16 characters long, and you can see there, 16 selected at the bottom. That's quite useful. And that's to ensure that as we switch around the screens, we always clear off any old text and don't have any leftovers. So there's the main menu, and then we have to actually print the items, right? Print the selected item anyway. So that's what we'll do, is what we'll show is the main menu, and below that we'll show the currently selected items, and then the up and down controls will allow us to select one of the items. So when we do an update display, we'll leave all of this serial stuff here. But what we'll also do down here is add something to print the current selected item. So we'll move the LCD cursor to that location, and we'll do a switch based upon the root position. Just the 3 cases. The first case, it's basically going to follow this, right? 1, 2, and 3. So depending on which you selected, case 1, case 2, and case 3. Hear that? See how it's complaining that these are the same cases? What does it say? The value has already appeared. So that's really good, right? It tells you everything, right? Anyway, 2, 3. Again, I'm going to maintain the 16 characters wide on this. Okay, so that means come in, we get the main menu, and then as we scroll around, the one that we've selected should show up in the bottom of that screen. Let's just test that and see if it works before we go any further. So here we have main menu and UI testing apps, and if we press down, just as following with the terminal, we get the different options. Alright, that's working pretty good. So let's do the rest of those menus and stuff. Root menu. Now, I've already prepared these, so I'm not going to waste your time with me copy and pasting this. So let's just do it. Submenu 1. And then same thing, we have the update display section. And just after the serial menu, I will add that. So this follows UI test buttons, second item, third item, fourth button item. Next one is submenu 2. Just after here, submenu 2, and submenu 2, it's got 5 items just after the print divider. We add those 5 items depending on the subpause. And what have we got after that? Submenu 3, submenu 3. Only got a couple of items, right? And there we go. First item, second item. And then finally we have this press test, which is a little bit trickier. Obviously we can't do all of this. There's some tricky thing I was thinking to do where we rotate the message around, but I think I'm not going to bother with that for this little demonstration. I will just put a very simple screen title. Maybe I'll do it after, it doesn't matter, before or after. So we do the screen title, button testing. Is that 16? Let me check. Yeah, 16 selected as 16. And I will also clear the second row with 16, yeah. Just to make sure everything's clean. Now right here I'm printing the test value. Yeah, now this test value I've updated it in quite a few different locations. It's going to get quite messy to do that. Let me shift this again up the top here first. Yeah, we'll stick it there, and then we'll do the serial. So what I think I'll do is inside this, I think I'll make a common routine for this, which prints the test value, and then I'll replace all of this. Let me do the replace first, and then I'll make the routine. See if I can figure out how to replace. We select, we go Control F, good, and click here, replace with print value test. So we need to make a subroutine called print value that will do the serial printing and do the printing of the same value to the LCD screens, just to save me going and having to do all this work. So replace all of those, and that's going to get red because we don't have one. So we're going to stick it in the tools display. Should be up the top here somewhere. Submenu, root menu. Look at that, see here on the right here you can see these little sections. That's pretty cool. It's pretty quick to skip around. Tools pressing, tools display. So doesn't matter, we'll stick it down here I guess. And it looks like that. So all it's going to do is still do that serial print line and the value. So we're going to receive it as I, and we're just going to print it like it would have done. But in addition, we'll set the LCD cursor to the 0, 1 position, and we'll print the value. And I'll print a couple of extra spaces here afterwards, just to make sure that we clear off any old value should it get shorter or longer or anything like that. And with that, I think we've actually finished, which would be pretty quick, right? Let's see if that works. Get rid of that. All right, let's go all in. There it is, menu on the screen. And what about over here? Yeah. Let's check all of these submenus first. First item, second item, third item, back around fourth item, fifth item, back to the first item. And obviously we can't do anything here. Cancel. And submenu 3. Just 2 items in there. Can't do anything. Cancel. And the first submenu, which is that UI testing apps like we made before. Let's go in here. Obviously second item and third item, fourth item can't do anything. Oh, there's an error there. I see that. Hang on. That's no good. So it remembered the down button state after I cancelled out. So that's definitely not what I wanted to do. And so when I actually went to it, actually took and went to that button testing menu, which is not the behavior I want. I mean, it's a bit of a messy display, a messy menu setup anyway, so it's not really a realistic setup, but I still don't like it, so I'm going to fix it. And I actually barely remember how to do this. Thank you. And what we'll do here is that we'll clear this button was down state for the except if we don't do one of the menus. So yeah, that makes sense. So if we do the menu, it's obviously going to go there. If we don't do the menu, we want to clear the button was down state. And because this is stupid C, we need to do a break here as well to terminate. I think that'll fix that little problem. Let me just send it again. I'm terrible at C, so you really shouldn't be following me. I don't mean that. Subscribe now. That's what you need to do. Subscribe now. There we go. Testing apps. Second item, none of these do anything, and then yeah, it doesn't make that error anymore. So that's working quite well. So let's go into the buttons test. Now we don't get all of that descriptive information, but the behavior should be the same in any case with the buttons and everything like that here. So if we up and down, as you can see on the screen, both screens, we get that changes. And we know that the short press of the OK doesn't do anything. but we get the message on the serial, and the long press of the OK sets it to 250. Obviously we don't get the serial message along with it, and we can change the value, and then if we do the triple button press, we get the 750 set. So yeah, everything works. And there you have an integrated menu system. You don't need the computer anymore to see the display. This would stand alone and work just as it is. So that's pretty much it for this explanation. I hope it's a good one. I don't know. Hopefully it comes out okay in the edit. We'll find out. So I'm not really sure what we're going to do in the next episodes. I am interested in looking at a few of those other displays. I also have an idea to look at some temperature sensors and a few other bits and pieces. But anyway, I think a lot of the comments are sort of driving the direction of the discussion as well. I'm not sure how much further I want to take this sort of menu structure discussion, but there are a few other things that I can talk about and discuss, such as how to manage your own custom settings and how to save those in the EEPROM and a few things like that. So those are probably things I'll cover over time. In any case, if there's something you want me to cover, then you should leave it in the comments. I am reading them and taking them on board. So anyway, we'll have to just wait and see what's coming up next. No matter what, I do hope you join me, so I definitely hope to see you then.